Okay, so number 51 from the book talks about a crate being dragged across the floor by two forces. One kind of that direction and one that direction. So we have force 1 being 88 newtons and force 2 being 54 newtons. And there's a 55-degree angle between them. Now this is top view. If I look at the side view, I'm going to have kind of a force applied this way. I'm going to have a normal force, and I'm going to have a force of gravity. It says it's 25 kilograms. It's initially at rest, but then it's accelerated. So I know that I've got an imbalance, an unequilibrium in the system. It says that the mu sub k, once it's moving, is equal to 0.350. So one of the things I can first solve for is what's this force of friction that will be pulling against the applied force. I can't quite label it on this other one because it's going to be the resultant of these two. It's always going to oppose motion. So it's either going to be this way or this way or this way, so I can't quite draw it. It's going to be exactly opposite the resultant of these two forces. So if I say that force of friction kinetic equals mu sub k times normal, then I can actually solve this, since in the x direction, or the y direction, up and down, normal and gravity are balanced. There's no acceleration there. So I know that my normal force is the same as my gravity force. So I can say mu sub k times mass times gravity. And I can then solve for the frictional force. And that's going to be 0.35 times 25 mass times 9.8 gravity. And that equals 85.75 newtons. The next thing I'll do is look at the components. Let's say that this 54 is along the x-axis. Let's solve to find out what's the resultant of these forces. All right. So if I sum up all the forces in the x direction, according to my top view, according to this view up here, I'm going to have mass times acceleration in the x, and I'm going to have then the cosine of 55 times 88 plus the 54 newtons. Okay. And if I do the math on that, I get 104 newtons. Then I'll sum up the forces in the y direction. Only in this top view in this section, so I have mass times acceleration in y. And this isn't the whole story either. I still have to figure out my friction and what direction it is, but this is going to get us the resultant. So now I get sine of 55 times 88. And there is no y component of the 55, so I'm just going to solve for that, and that gives me 72 newtons. So now I can put these two guys together and find that my resultant pull is going to equal the square root of 72 squared plus 104 squared, which equals 127. Okay. So now I know that my force is 127 newtons. So my sum of all of my forces now is equal to 127 newtons one way minus the friction force from above, which is 85.75, and that equals the mass of the box times acceleration. So if I do the math on that, I get 41.25. Divide that by the mass, and I get my acceleration. In this case, it comes out to be 1.65 meters per second squared. Okay. If I want to now take that and plug it in to find the angle at which it's going to move, because it wants the magnitude and direction. So now I'm going to go back to these two guys and apply an inverse tangent. 72 divided by 104, and I get 34.7 degrees above the x direction. So there's my direction, and there's my acceleration for problem 51.